This is Mrs. Frazier, and I'm going to go through your algebra test review for laws of exponents as well as simplifying radicals. So starting with the laws of exponents section, we have x over -2 and 2x to the -5th. I'm going to expand mine out, knowing that x to the -2 first. I'm going to actually move that to the bottom, because a negative exponent is going to actually be the reciprocal. So I'm going to still have my 2 on the bottom because it doesn't have a negative exponent, but the x to the -2nd is going to move to the bottom, and the x to the 5th will move to the top. Now expanding that out, I actually have x times x times x. I have x 5 times. And 2 times x times x. So I know that x divided by an x will equal 1, so I can eliminate 2 x's on the bottom and 2 on the top, because that will equal 1. And I'm left with 3 x's on the top, so I can rewrite that as x to the 3rd, and 2 on the bottom, over 2. Okay, so moving to the next one, I'm going to start by rewriting, moving these negative exponents. So I know x to the 7th now will be on top, and x to the 4th will be on the bottom. And I still have 3x to the 2nd to the 0 power. Now I know anything to the 0 power equals 1. So if I'm looking at this 3x to the 2nd to the 0 power, all of that's going to equal 1. So I'm going to eliminate all of that. And I'll just have x to the 7th and x to the 4th. I'm going to expand those out. And when I expand those out, I can see that I can eliminate, for each x on the top, I can eliminate 1 on the bottom. So that eliminates all 4 x's on the bottom and 4 x's on the top. So I'm left with x to the 3rd on the top. And that's all I have for my final answer. Okay, so I think your test review should have a 4 here, but if it doesn't, go ahead and change that. So I want to take this to the half power, but we're going to expand it out before we take it to the half power. So I can actually simplify 4. I can break it down more. It's called prime factorization. So I really could break that 4 down into 2 times 2. So I'm expanding all of this out. So x to the 6th power, and then y to the 4th. Now I want all of this to the half power. So what I'm saying is I literally want half of each of these. So I want half of that 4, or the prime factorization of that. So that leaves me with the 2. I want half of that x to the 6. So that would be x, or 3 of those x's. And I want half of y to the 4. So that would be 2 of those y's. So I will be left with 2 x to the 3rd and y to the 2nd. Hopefully you can also see what we did here is we found the square root of 4, and the square root of x to the 6th is half of this, so x to the 3rd, and the square root of y to the 4th is half of this, so y to the 2nd. 4x to the 9th over 8x to the 10th. I could actually expand these out some more, so I'm going to show you both ways. So I have 2 times 2, and then x to the 9th. And then 2 times 2 times 2, and x to the 10th. Now, I hope you know that 4 over 8 is actually 1/2, but now hopefully this will help you see why this is very helpful to see it visually. So we know 2 divided by 2 is 1, so those cancel. 2 divided by 2 is 1. So I'm left with that 2 on the bottom, so that 1/2. And then this x cancels that one, and I'm going to continue with that. And I'm left with 1x on the bottom. And I have nothing on the top, but we know that really 1 is there. 1 is always there. So I have 1 on top, and then I have 2 times x on the bottom, so 2x. Okay, so x to the 4th to the 3rd. So I'm going to expand that out. So literally that's saying that I have x to the 4th 3 times. Okay, and then I have times 3, and x to the 5th to the negative 2nd power. Well, really that x to the 5th to the negative 2nd is going to go on the bottom. So this is like x to the 5th to the 2nd on the bottom. Okay. So I'm going to expand this out even a little further. And I always think it's better to expand it out if you're not quite understanding. I just think that it's less to mess up. So x to the 5th to the 2nd power is like x to the 5th twice. So really I can rewrite all of this as this. Then I can rewrite all of this, expand all of them out. So I have x to the 4th 3 times. Times 3, and x to the 5th. And I have that twice. And now I can start eliminating. Okay, so I have nothing left on the bottom again, but I have 2 x's on the top and a 3. So that's going to be 3x to the 2nd. Okay, 2x to the 3rd times x to the 2nd times x to the negative 2nd times 2x to the 2nd. So again, I'm going to take this and go ahead and move that to the bottom. I'm going to rewrite all of this, but I'm going to also take care of this at the same time. So I have 2x to the 3rd power. So I have 2x 3 times. So I have 2x times 2x times 2x. Or I actually could write this as 2 times 2 times 2, so the 2 3 times x times x times x. And then I have x to the 2nd. But that x to the negative 7th goes to the bottom. So I'm going to write that down here. And then I have 2x to the 2nd. So I have times another 2 times x times x. Okay, so let's take care of the 2 times 2 times 2 times 2 first. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, now let's take care of my x's on the top. Well, actually, we don't have to take care of them on the top. We can go ahead and start eliminating those. So looking at my x's. So you can see that I eliminated all of my x's. So by eliminating all of my x's, that actually means that that would equal 1. So 16 times 1 is another way to write that, but we don't need to write 16 times 1, so my answer is just 16. Okay, so we're going to stop the video here, and then there'll be another video for simplifying radicals, and then there'll be a third video for doing the application problems down at the bottom.